All right, so the last one that we're going to look at says, what is the largest integer value of x that satisfy where f of x is still greater than g of x? So f of x is going to be equal to 6x minus 1, and g of x here is going to be equal to 0.5 times 2 to the x power. So again, we'll set up our x, f of x, g of x table. And we're going to start with number 1. Okay, so 6 times 1 is 6, minus 1 gives us 5, and 2 to the first power, remember we always do our exponents first, 2 to the first power is 2, half of 2 is 1. So right now, f of x is greater or equal to g of x, but we expected that because it says what is the biggest number where this is still true. So we're going to have to keep going until this is no longer true. All right, so our next integer value that we'll pick is 2. 6 times 2 is 12. 12 minus 1 is 11. And here, 2 to the second power is 4. Half of 4 would be 2. Still holding true that f of x is greater than g of x. Okay, 3. Instead of continuing to plug numbers in, at this point I'm going to use my patterns on my table. So this guy is a linear pattern where every single time we're adding 6. Remember, our slope talks about an adding pattern. So we're adding 6 each time. And this one is an exponential pattern. Remember, this is our pattern part, and we're talking about multiplying by 2 each time. So if I can see my equations and I know my patterns, then it's pretty easy for me to fill in the rest of my table doing very little math. So if I add 6 more, I get 17. If I add 6 more, I'm getting 23. 6 more gives me 29. 6 more gives me 35. I'm going to stop there on that one for now. I'm going to come over here and start this one. So it looks like I'm doubling it each time. So 2 doubled gives me 4. Doubled gives me 8, 16, then 32. All right, so I'm going to check out where I'm at. This is still true. This is still true. This is still true. All right, it's still true there. So I'm going to keep going. And I'm going to end up adding 6 more, giving me 41. Doubling this again gives me 64. And we can see that's where that shift happens. So the very last x value where f of x was still bigger or equal to g of x before it changed was 6. So our answer, what is the largest integer value of x that makes this true? Our answer here would be 6. I am going to show you what that looks like on Desmos, because if these are calculator active, then we should use calculator. So I'm going to type in my f of x function up here. 6x minus 1, and then our g of x function was equal to 0.5 times 2 to the x power there. All right, I'm going to go back home, see if I can get a good picture here. All right, and it does look like, let's see.